Okay. Now, again, just a reminder, the learning outcome for this module, we have 3. We will deal with one-dimensional problem, 1D, and then we look at different element types. After that, we deal with 2D problems, two-dimensional problems, and then we will use a commercial finite element method package. In our module, we will use ANSYS software, right? So these are the 3 learning outcome for this one. And just a reminder, my email address is this one, yeah? It's not the student that one, not. So use this one for my email. And you already have my contact number in the WhatsApp group. So again, for this module, it consists of 40, 60 percentage, yeah? So have a look in it, and you need to score at least 30 out of 100 for the final. Attendance, you need 80% to sit for final exam, yeah? Okay, we already completed fundamental concept last lecture or last week. So today we're going to look at displacement method, stiffness method for this week. Okay. Now, chapter 2 is deal with a method that we use to solve in an FEM. We'll focus on stiffness itself. We will look at 4 things. It depends. Maybe today we only look at one definition of stiffness matrix. Then we follow up with the next lecture. Okay. Now, what is stiffness matrix? So on the screen that you see here, we have one element. So for finite element, we look at element and global, means the whole structure. So last lecture, we discussed about the technical word called discretization, or the meshing word we break down the whole structure. So this is one element. So one element consists of 2 points, where usually you will draw 2 nodes or 2 points, and then for this case is spring, so you use a spring spring symbol, right? And then you have x direction, positive to the right. Okay, so this is to represent one element. Recall that we have covered one simple equation last lecture, which is F equal to KD. F equal to KD. F is force, K is stiffness, D is the displacement. So as you can see here, last lecture also we mentioned the shape of the bracket that we use. For force and displacement, we use a curly bracket. And for the stiffness or constant value, we will use a square bracket. So be careful on the shape that you use. And if you see a small alphabet, it means element. Okay, so if you use a small a normal letter or small letter, a small alphabet, F and K in small letter, means that you are referring to element. If you are using a capital F and capital K, it means that you're looking at the whole structure. Okay, so on these slides or on your screen here, you're seeing that we're using a small f, small k. D displacement always small letter, right? So only you look at the form of the equation that we use. The first equation for today is F equal to KD. Force equal to stiffness matrix times the displacement. All right. So F is the force, not force at here and here. D is a node displacement, which is here and here also. What is happening to this node? And then K is a stiffness matrix. So for today, we're going to focus on the K element. Okay. Any questions so far from all of you? Any question?
No.
Clear? Okay. Ask me question if you're not sure. All right. Today going to be a simple lecture. All right. So F equal to KD. Now the next one, the one I updated a diagram on the screen here. On the top is one element. If you combine all the elements, you will get a structure. You'll get a structure. Then you use a capital F, capital K, and remain the small displacement, small d for displacement. So in exam, if you're talking about element, you write F equal to KD, small f, small k, small d, you get 1 mark for this equation. And if the question asks you to solve the whole element or whole structure, then you write F equal to KD, capital F, capital KD, you get another mark. So by writing these two equations, you get 2 marks already before solving the question. So it's very easy to score for this module. So write the equation, you get the marks. Okay. Just only need to be careful on the bracket shape, curly, and the square. Don't confuse, don't write the wrong shape. Although it's a free mark, but I hope you appreciate we try to help you to score some marks. So don't lose all these easy marks. Okay. So how we differentiate the name for capital K and the capital F? The word called global. If you see the question asks you to solve global something, global force, global displacement, then you use capital letter in your formula. Okay. If you look at element, if the question asks you to solve element forces, displacement, or even stiffness, you will see the word nodal, node at a node something, and node 1 and node 2. Then you use a small alphabet in your formula. Okay, F represent force, but is in the global dimension. And then the global coordinates displacement. Although it's a global, but we still use a small d. K is capital K means the whole structure. Okay, so I think it's quite simple. Quite simple. Only need to remember one simple equation, F equal to KD. Just need to be careful on the presentation of your answer. Either capital letter or the curly bracket or the square bracket. You have to be careful on this one. All right, let's look at one scenario. So let's look at a spring structure. So spring structure, as you can see on your screen, this spring consists of 2 points, one on the left, one on the right. So before you solve question for finite element chapter 2 question, normally you will extract the element out and then you draw 2 points and then the spring structure. Again?
So let's go back on the global structure.
Again, your question? I'm not sure what you're asking.
I was just saying that can you go back on the global structure for it a bit?
Oh, this one, yeah?
Yeah.
Okay. So any question?
I just wanted to have a look at it again.
You can you differentiate the differences between the top one and the bottom one?
Yeah.
Yeah.
Now I can understand.
Yeah. Okay. So one is if you use a small capital, F equal to KD, the F is small, K is small, it refers to individual element. If you write capital F and capital K, it means you already look at the global scale or the whole structure, the combination of all the elements. Okay, try to get the idea first. Because later you look at lots of equations. So this is the very fundamental concept. If you can understand these two equations, the differences between these two and the scenario we choose, then you are fine. If not, later you're confused. You will put something in the element you will mix up these two, then you'll get the wrong answer. We will solve for element first. We will break this structure into this one. Normally we start with the small capital, then we solve for one element. Then after that we will combine all our answer into global. I will teach you how to do it. But at the moment, you should know that we have two scenarios. One is we look at individual element, and another one we look at the whole structure. And then the formula follow as the what you see on the screen here. Brian, you able to see the differences?
Yes.
I mean, can. Okay, any one of you have question, just stop me and then ask me to explain if you're not able to understand. Or it doesn't look look good to you, then you ask question. Okay, for today's lecture, we look at spring structure. So as you can see, the spring structure consists of this symbol. All right. So in the question, either in your test or final exam, if you see this curve, this saw shape, this up down lines, it means spring structure. Okay, and every time we solve, you or look at a question, you will see there are 2 points on each element. Yeah, we'll use the word element means we look at one individual item here. So if you look at element, you will always have 2 points, one at the left, one on the right. One is at the one at each end of the element. So in this case, we use spring. So you have a spring structure, and you know that spring have the spring constant as you learn in the physics class. All right, F equal to kx. Right. So how you calculate the force of the spring in your physics class? You always write F equal to kx, right? In your physics. So spring force equal to stiffness of the spring times the displacement of the spring. So when you draw the element symbol or you draw the element diagram, make sure you put the K there. And in this case, as you can see, the K symbol is a small k. Again, if you accidentally write a capital K in your answer, I will assume this one is a whole structure. Then you'll get the wrong answer. Okay. Then you have the force on each side. So the force also will represent as a small f because it's an element. And you see that there's a subnote there. F1x. F1x represent point number 1. X represent the direction of the force. Okay, and throughout this module, we assume all the force along x-axis or to the right is positive. So you write small f sub 1x represent this force. Same with point number 2, you have a force at point number 2, F2x. 2 represent point number 2, x represent in x direction. Because when it comes to final exam or when it comes to your test, we will orientate the object. So you need to carefully label your element. Okay, so this is the first start. So you draw the symbol, draw 2 points, put 1 for point number on the left, 2 for the point on the right. Write the stiffness matrix K, small k in the middle of the diagram. And then L, it depends. It's not a compulsory, but it's good to write the length for the element. Okay, so we already have the force on the left, force on the right. How you know which one is which one? By the symbol that you use in your answer. So F1x represent the one on the point number 1. F2x represent the one on the right or on the point number 2. And then you know that the spring equation F equal to kx that you learn in physics, x represent the displacement, how far that you pull the spring. So there's a movement on the spring. So if you move in point 1, in the x direction, we will use the U symbol because previously when we talk about axis movement in axis, if the movement in x-axis, we will use the small u. If the movement in y direction, we will use v. If the movement in z direction, we will use w. Okay, recall all this notation. All right, x movement, we will use u. Displacement to along x-axis, we use u, and to the right is positive. Y going up is positive, and any displacement along y-axis, we use v to represent the movement or displacement. Same with the z, we use w. So be careful when it comes to tests or final exam. Normally, you won't see y and x. You will see y and z. Just keep your hints. So normally, you won't see y and x. You will see y and w. Sorry, y and z. So in your answer, you'll use v and w instead of u. Okay, take note. Yeah, so these are the fundamental for how you write your answer. Okay, any question for the notation? F, U, F2X, U2, anything that you're not sure, ask me now. Okay, seem everyone of
No
you.
questions, sir.
Good, all right. Let's move forward. So the rest you can read on the screen, yeah? I'll just highlight the important one. Now, since this morning, I keep repeating one equation, one equation. Ashmal, are you there? Ashmal?
Yes.
Yeah,
sir.
what is the equation that I keep repeating this morning?
F equal to KD.
Yes, correct. So on the screen here, excellent, Ashmal. All right, so if you look at the screen on the right-hand side, so F equal K D. Again, apologize for my writing. I'm writing using my mouse. So for F, you use a curly bracket. Oh, this one is a square, sorry. K is a square, D is a curly. So you write this one, you got 1 mark. If you're given a spring structure or one element, to solve one element, you write F equal to KD, small letter, small k, small d, you get 1 mark. And then you expand. You expand using matrix method, or we call it direct equilibrium approach. All the force inside the element equal to 0. Okay, so how we expand the force element, force component, on your diagram, you have two force, right? Point 1 and point 2. You have F1x, F2x. So you combine them into a matrix form. F1x, F2x. Write carefully, curly bracket, equal K. We have 4K there. K11, K12, K21, K22. 1 is called the first notation. 1, this one is referring to column, row, sorry, row. This one is column, yeah? This is row, this is column. So you have 1, 1, 1, 2, K21, 2, 2. So be careful and also take note on the numbers. So all these, the matrix you can break into a parking lot. This is the 2 times 2 matrix. If you don't understand what is 2 times 2, you need to go to appendix. Okay, so this is a 2 times 2 matrix, meaning you can break it into 2 column, 2 row and 2 column matrix. And be careful on the parking lot that you have here. So you cannot park K22 here. You cannot park K22 here also. It must park here. If not, you will get the wrong answer. Then you have 2 displacement according to the diagram that you just draw just now. You have displacement at point 1, so U1 you write here, and displacement at point number 2 you write here. Okay, The next is just the application of what you learned in the matrix or the combination of equation. All right. So this is just a side note for you. So if you use a small letter, it means node force, a local node force. Local means is referring to the element itself. We haven't combined in the whole structure. We extract one element out. Then the D or displacement here, we already changed it to the direction of that displacement. We use U, small u, U1, U2. All right. And from here, we can know that our structure, our element here only have two degree of freedom, U1 and U2. You can only move in the X direction. Okay. And positive. All right. Okay. So this is how we transform our equation into this one. Okay, just a side note. Just a side note. How do we apply this equation? How do we change this matrix form into equation? Actually, we have two equations in this matrix form. We can write f1x equal, meaning this one, equal to this one times this one. Okay, now how do we times? We will get, I will change my color. We will take this one times this one. So you will get K11 times U1 plus another one, K2 times this one. Yeah, this is how we use the matrix to build equation, or from equation, how we convert into matrix. So the second term, U2. So if I ask you to write the second equation, are you able to write? If you're able to, are you able to by this illustration? So the second one also have the equation. Okay, so don't confuse. F2 referring to the F2 column. So don't confuse with the parking space that we have. So F2 equal to this column, this row, times this column. Okay, so you will get this equation. Any question so far for the equation? How we convert matrix form into the normal linear equation? Good, huh? So these are also one of the error student mistakes in the exam. The student don't understand how to, even the equation is given in a question, the student don't know how to convert it back to matrix, or don't know how to put in the parking lot. All right. So we just assume this one you have a three building parking lot. Right. So on the left is force, the middle one is the matrix, the third one is the displacement. Okay, as long as you clear with the location and all this, then you are fine. Okay, so far we are keep repeating F equal to KD. All right, now the next one, as you can see on the screen here, on the top here, we have two elements here. So on the top, you have one element that don't subject to anything, means it's just a spring with no force. All right. Of course, this X is just a direction for you to refer. Then after that, we apply tensile force. Okay. So just to recall, you have four types of forces if you study mechanical. If you're pulling at both ends, if your force is pulling, I'll use capital capital F. All right. So if you have force pulling at both ends, you have a tensile. Apologize for my writing. You have a tensile forces. If the force is going in both ends, meaning you are compressing. You have a compressive or compressed force. Okay. Another one, you will have a tensile compress. Another one is shear. Shear, it means that you, okay, I need to draw in 3D. If the force is parallel to the surface, move parallel to the surface, this force is parallel to this area, you will get shear force or shear stress. Shear. All right, as long as the force moving along this one. And then you have a rotational or torque, meaning you try to twist something, you try to turn something, you have a torque. How you calculate torque? Just recall back, you learn in your physics. You have a force times the distance which is perpendicular to the surface and force. Combination of force and D, you will get torque or moment. T-O-R-Q-U-E. Or moment. Okay, so these are the 4 important forces that you will see throughout this module. Tensile, compress, torque or shear. So again, if you look at the force along x-axis, this force will be positive. I'll start reminding you on the positive and negative side. If this side is positive force, this force is negative because it's going opposite of the x direction. This force is opposite of the x direction, so this force become negative. This can become positive. Yeah, try to understand the green color sign that I just write. If the force is along x-axis, the force become positive. If you go against or opposite the x direction, you get negative. All right. So this is how, again, for this module, there will be one section that you need to explain your answer. Let's say you calculate until the end, you get negative. Usually the question will ask you to explain what is the direction or what does this value mean. You need to explain whether you go to the left, go to the right, or you go into the surface or come out of the surface. Now you need to explain. Let's move forward a little bit. Okay, so we remember we have 7 steps. So first one, we just keep repeating these 7 steps throughout this module. Step 1, select element type. So element type, the most simple one, we have a 2D, 3D, and then symmetry and so on. So if you cannot remember, go back to the previous slides. The slide is available on Moodle. So in this case, we only have a simple case where you only have a 2 node. We use 2 node to combine the element. So this is a simple element type, which means we have a 2 node. Okay, remember, shape of the element you can use. It depends on the type. So either you combine with 2 point, you can combine the shape. This is the most simplest shape that you can have. Or if you use 3 point, it will become a triangular. Yeah. Or even in a simple line, you can use 3 point also. Means you do discretization, you meshing, you cut the element into a smaller pieces. Okay. So in this case, we only use 2 point to represent our element type. Second, we use equation, displacement function. For spring, again, we'll use F equal to Kx that you learn in your physics. And then call back the matrix form that I just showed you just now. We did this one. F1x, F2x equal to K, the 4K value, and U1 and U2. So I think this one is your new equation to remember for today's lecture. This is the expanded version for F equal to KD. So this is today you need to remember this one. Okay, first step, element type, second equation. And the third steps is to call out what you learn in your finite element analysis, the strain and displacement equation, stress and strain relationship, which give you this one. Okay, so if you look at this diagram on your screen, the tensile loading is pulling at both ends. So T represent tensile load. The pulling or forces are pulling at both ends, pulling out along the element axis. And you have displacement at point 1, displacement at point 2. The arrow is drawn to show the positive direction. All right. All right. Now, of course, in realistic, you know that when you pull this side on the left, you pull on this side, the U will go this way, correct? The U1 will go left-hand side. So later, you will get the negative sign because it go against x-axis. So the first equation for the element is displacement or deformation equal to U2 minus U1. You take what have displaced, what have been moved at point 2 minus point 1. So that's why there's a negative there. Actually, it's U2 plus U1. But you look at the direction. In this case, we know that the U1 is moving to the left. So straight away, we use negative sign. Okay. Or just keep it simple. To find displacement, you just take 0.2 minus 0.1. Okay. U2 minus U1. Okay. So when you come to your final year module, we need to be careful on a positive negative sign. So in this case, I already explained why there is a negative there, because logically you will see U1 if you pull on the left hand side opposite of the x direction, you'll get negative sign because it's going to the left instead of going to the right. Okay, so the second equation for today, deformation or displacement for elongation for the spring will equal to U2 minus U1. Or you can write F equal to Kx in the according to the question or diagram symbol. This represents F. So in this case, we are given the symbol of T. So we use T equal to Kx. In this case, the deformation was given as delta. So T equal to K delta. Right. So in the question or in your exam or test, if the diagram already give you a symbol, for example, in this case, the symbol of force already give you a T. So in your answer, please remember to change it to what is given. Don't continue to solve using the general equation. Of course, you write F equal to Kx, I'll give you 1 marks, but you will miss all the marks for the next steps because you're not following and you're not answering the question. So remember to look at the diagram given and then combine what you have learned. In this case, the force is T. So write the force in the T, capital T form. K is the stiffness. Copy back, use back. The displacement of the spring, yes, you learn in physics, you use X. But in the question, you will mention deformation delta. So you use the delta form in the question. Okay, you need to be very clear in your answer. So substitute back of the definition of deformation just now that we already calculate or we already write out U2 minus U1. So substitute back So you will arrive at the equation that looking for in the question, where it asks you to derive the stress-strain relationship or strain displacement relationship. You get 1 mark for this answer. Okay. The next steps. Once you have the relationship equation for the stress strains or strain displacement, then now for spring you don't have stress strain because spring only expand and compress. You only have strain and displacement equation. Okay. Okay, then this one you see. Then we start to derive the stiffness matrix already. Now this is the new thing that you learn in this module compared to other module. We will look at matrix, stiffness matrix K. Okay. So we will start looking at the force. So we start to call back what we learned this morning. We look at point 1. Point 1, you have force. So at point 1, we write F, small f sub 1x represent, if you look at F, 1x, small f refer to element. Small f refer to element. Sub 1, it means point 1, x mean in x direction. So you rewrite F1x equal to negative t because the t is going to the left. So you get negative t. You look at point number 2. Point number 2, you write F2x equal to t. This is a positive sign because it's going along the x-axis. Okay, move forward. Then you rearrange the equation. T equal to negative F1x, and the right hand side for point 2, t equal to F2x. Now, why we need to do this? Continue forward. Now we rewrite the equation. For point 1 on the left hand side, this column, left hand side, we are referring to point number 1. What is happening to point number 1? T equal to minus F1x equal K times the displacement U2 minus U1. And for point number 2, you have T equal to F2x equal K times the displacement of 2 point U2 minus U1. Now you're having a referring to point 1 and point 2. On the screen here, you are having 2 equations. Now I want you to try to transform these 2 equations into matrix form. Okay, I do it slowly. Stop me if you're not able to answer. I'll do it slowly. Okay, I transform my first equation here, negative. I pull my negative sign to the right hand side. When I pull my negative from left to right, my U2 become negative, negative become positive for U1. So that's why this one transform to this equation. F1x equal to K times U1 minus U2. Clear, everyone? Looks logic to you?
Yes, sir.
Okay. Pay attention because this is very important. Try to understand this one. Okay, same with the point number 2. Point number 2, you write F2x equal to K U2 minus U1.
So
Yes.
doesn't K also become negative?
Which one?
For,
Oh, okay, for this one, right? So if you move your negative to the left, you only time negative there, right?
Yeah.
Yeah. So you time there. So what happened to this one? Although this okay, if you expand this one, what you get? KU1 minus KU2, correct? The negative sign already there. Yeah, like you say, it's negative, but you already times inside there already. Do you see it, Brian?
Oh, okay.
Do you see it? Do you
Yes.
see why this one become positive? Because negative U1, negative K times negative U1, you get positive KU1. Then the negative K times U2, you get negative KU2. But you just factor it.
Okay.
Got it?
Got it. Yeah.
Okay, good. Again, stop me if you're not able to digest what you see on the screen. Clear your doubt before going to next chapter, because this chapter is very important. You understand what we're talking about this chapter, you have no problem for your test or for your final. Try to understand. There's a reason why you put the numbers in a certain way. Okay, we have two equations now. We'll put them into a matrix form. I put on the screen here. So the one on the left is 0.1. Normally, I will just draw 1 and circle it. If I refer to 0.2, I will just circle it, representing 0.2. We will put them in the matrix form. Just now, I explained how we expand from matrix to equation. Now we put the equation back to the matrix form. So you put in this form, F equal to KD. By looking at the equation itself, it actually is F equal to KD. F equal to KD. So you just put what you see on the screen. So you put them in the matrix form. So for the first one, you put F1x equal the first row. You have the positive, right? Positive K, positive negative K times the U1, U2. Okay, so if you expand this one, F1x equal KU1 minus KU2. So you just put them in the matrix form. So F1x equal the first row and first column represent the first equation. So you just pop the number. So this one represent the first one. This one represent the first one. So you put the K. Oh, maybe I will just use the different color. So you just put your K here. Park the first. Again, you know that your matrix is the parking lot. This is the first element or first point. So this is your first K. So you pull your K over here and you pull your second K into the parking lot, this one. Same with your U1 also in the parking lot, U2 in the parking lot. Okay, make sure you know how to park the numbers. Okay, same with the second equation. This one. Yeah, so this step is important. Super important. Super important. I'll draw a lot of star there. It's a very, very important skill that you need to know how to convert equation into matrix form. You need this skill throughout this module. Throughout this module. You always need this skill. We will derive equation, then we'll put equation into matrix form. Try to understand how to do this one. If you don't understand this one, you refer to Moodle Appendix A. I already upload the matrix appendix there. Download, go and read. It's very detailed there. Okay. So we just combine and then try to check. This is we already done for the derivation and we just try to check. So the middle stiffness matrix K minus K minus KK. This is a 2 times 2 matrix. This one represent the small k with the square bracket. A label on the screen here. Small k with a square bracket. We call it local stiffness matrix. Okay, we call it local stiffness matrix. So every time that if the question asks you to solve or derive the local stiffness matrix or element stiffness matrix, you remember to write the small k and not the capital K. Small k inside. And if it's the spring that is under tensile force, then you can have a k minus k minus k k. Standard already, yeah? So this is the standard equation. If you write this one in your answer, you get 1 marks. Without anything yet. Without doing anything yet. You just write this equation, this matrix equation, to represent a spring structure under forces. Which means how you can write this equation. So you will always start with 2 points. Label 1 and 2. Draw the spring. Put in the K value. Of course, the length. Length. Of course, in this case, the length, don't do anything yet, but in the further section, we will include L. Because here we only look at the spring. Spring only have the strain and displacement equation. And then in this case, the force is going out like that. So you are having this equation. All right. So you have a U1 is going to the left. That's why you have a negative sign inside the matrix. U2 to the right. Force 1 go to the left. Force 2 go to the right. So when it comes to exam or test, draw the diagram, write the equation, diagram 1 mark, equation 1 mark. By just these 2 actions, it will score you 2 points. You score yourself 2 points. Okay, again, it's very easy to score as long as you follow along the standard method that we have. Okay. So if you look at this matrix form, K minus K minus K, K, or if you look at the appendix, you have any numbers, 1 minus 1 minus 1, 1, or you have any numbers, 5 minus 5 minus 5, 5, or any numbers. As long as you have the negative at the diagonal, positive at the diagonal, then we call it symmetry. Okay, symmetry means that this one same number, this one same number. Okay, so also why I mentioned this one again, the question that you will see always asks you to explain or call out to prove or to explain whether your stiffness matrix is a symmetry matrix. You need to know how to explain. Okay, symmetry matrix. Prove or explain the stiffness matrix is a symmetry. So this is the way you explain it. The numbers of diagonal, or just write the stiffness matrix and then you explain. Numbers in the diagonal direction is the same. Yeah, they give you some points for your exam already. So symmetry, this word. Square and singular. What is a singular matrix? If you don't know, go and look at the appendix. Determinants equals 0. So what is determinant? You learn in your advanced mathematics. You need to know. And if you forget already how to find determinants, is also inside appendix A under matrix. Okay, or you don't know, go back to your advanced mathematics or Form 5 or SPM advanced mathematics textbook. All right. Then we combine what we learned. Again, small f is an element, small k is an element. U displacement, always small letter. U, it just tell you that it's along x-axis. If you see V, it means Y direction. If you see W, it means Z direction. Okay. Number 5, you put everything in together, where you will combine them to transform them from element into the full structure. Full structure, the word, come up with the word global. You will need to use the capital K, capital F. Now, what does this mathematics symbol means? It might be new to you, but you learned this before. It means that you combine all the small elements together. This symbol is the sum of all the small elements that you derived just now. And same with the force. If you combine all the small elements, the forces that you found, then you become a global force. You become a global stiffness matrix. Okay, start to familiar yourself with the technical word that we use for this module. Global, local, right? Local, it means element, individual element. Global, 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 it means the whole structure, the whole picture. Okay. So I just write on the screen here. Yeah, again, be careful on the shape of the entity that you write in your answer. Stiffness matrix, always square bracket. Force or displacement, always curly bracket. Be careful on the symbol. Then you solve for the unknown. Any unknown inside the equation, using either the element. Sometimes you can solve in the element stage. If you cannot solve it in the element, then you solve in the global dimension, which is the capital F. Then you solve for the, normally we solve for D. You know that you have equation F equal to KD. We will go for displacement first. We will solve anything that we know or we can capture from the diagram. After that, we will find this one. It will give you the answer of the force, the missing value of the force. Okay, I think we stop at the general steps. Then the next lecture, we'll look at the application of the F equal to KD, or these 7 steps in our next lecture. Okay, let me stop the recording.